Hey everybody, in this video I'm going to go through our lesson on domain and range of quadratics, and I want us to begin with recalling a little bit about domain and range. So domain for a function, that is the set of all x values, or what we call inputs of a function, and we will read that from left to right. Your range, that is the set of all the y values, or what we sometimes just refer to as the function values, because f of x is the same thing as y. And these are really just talking about the outputs. And this is read from bottom of the graph to the top. That way you start with your smallest values. We've talked about this before. Now we're going to apply it kind of specifically to the quadratics. And let's note that quadratics are usually continuous unless we have like confined them in some way. We've set some constraint. So what does continuous mean? It means that it does not stop as we look at it from left to right. So it runs left to right, either direction, without stopping. So quadratics are continuous usually because they are going either to the left and to the right upwards, or they are going to the left and to the right, but downwards. So because quadratics are usually continuous, this means then that their domain is usually all real numbers. Unless, again, it is some piece that you are just looking at. You are looking at part of the quadratic function and it's been cut off when x is 1, and then it, there are some limitations, but usually when we're talking about just a general quadratic, the domain is all real numbers, meaning all values of x, because it goes forever and ever and ever to the left and to the right. We have all real values. Now, the range, let's see, I'll go to red. The range depends on the minimum or the maximum value of your graph. So this really, again, that's your vertex. So it depends on the minimum or the maximum from the vertex, which is always that point H comma K if you're looking at it in vertex form. Now, if you have a parabola that is pointing up, then you have a minimum value. I felt wrong. Minimum. And your minimum value tells you then that your range is all of the y values that are above this point. So y is greater than or equal to whatever this value of k is in your vertex, because k is your minimum or your maximum value. So this means that f of x then is greater than or equal to k. Or I could even say that our range begins at k and is equal to it, and then it has every value after that to infinity. So that's if we have a minimum. If our parabola points down, now this vertex is a maximum. So this means then that my range is all of the y values that fall below this maximum value. So the range is all of the y values that are less than or equal to k. Or I could say f of x is less than or equal to k. Or if I'm reading from the bottom to the top, I have all of the negative numbers I could possibly imagine. Our range is all of the negatives, so negative infinity all the way up to whatever this k is, and then it stops right there. Okay, so let's look at some examples. Number one, we are going to find the domain and the range of the function. And this graph is in the OMHS. You can either print it out or just kind of draw the best sketch you can of it in your own notebook. So we want to find the domain and the range of this graph. I'm going to start with the domain. And I want to know, oh, I didn't mean to do that. Well, oh, that's fine. The domain, remember that's all of our x values. And we want to read that from left to right. Now, this graph does not have a clear starting or stopping point. This is a continuous graph, right? I can assume this is going down, but also it's going down to the left and to the right. So because I have all of the negative values I can think of, and then I have all of the x values that are shown on the graph here, and then that continues, and we have all of the x values that get bigger and bigger and bigger, then our domain then is all real numbers. So domain, all real numbers, which really means we have from negative infinity to positive infinity as our domain. Now the range is a little bit different. If I start at the bottom of my graph, oops, I didn't mean to do that. There really is no set bottom because, right, it goes down forever. But I do have a clear stopping point, right? Our range is all of the negative values up until we hit this height right here. So this height is 3, right? That is the tallest point on our vertex or on our parabola in general. This is the point -1, 3. So our range is all of the values below this 3. So our range is all y values that are less than or exactly equal to 3. I could also write this as f of x is less than or equal to 3. Or I could say that we have all of the numbers, all of the negative numbers from negative infinity all the way up to this point 3, and it is equal to 3. So if you forget, the parentheses means not equal to, and the bracket means it is. So let's even make that note. Parentheses not equal to. Well, there we go. And then the brackets means it is equal to. And it is equal to that point, right? We do have a point where y is equal to 3. I do not have a point where y is specifically equal to negative infinity because that doesn't make sense. Negative infinity is not an actual number. All right, let's do number 2. So we're going to use graphing technology to find the domain and range of f of x equals x squared plus 6x plus 1. So I am going to open up my Desmos and I am going to reshare my screen. And do it like this. There we go. So I'm going to type in our function, and I can honestly just type in x squared plus 6x plus 1. Oops, I didn't mean to do 2 6s. And I notice that this parabola points up, and it goes forever and ever and ever to the left and to the right, right? But we do have a lowest possible value here. But first, I want to make a note, and I don't know why my notebook's not, oh, there we go. I want to make a note that since this graph kind of looks like this, and it is going up and to the left and right forever and ever and ever, our domain here has to be all real numbers. But our range is dependent upon what our vertex is. So let's figure out what this vertex is because that then has my minimum value. So let's see. So looks like, and I can click right on it and have it highlight the point. It is -3, -8. So the minimum or the lowest value that this graph has for y in the range is -8. And then I don't have any y values below there, right? My graph isn't below that point. So I can just, I think, go like this. There we go. Our range is all of the numbers or all the values of y that are greater than or equal to -8, because this vertex is at -3, -8. I could also write this as f of x is greater than or equal to -8. Or I could put this as kind of like, a sandwich sort of deal. And I could say, or not a sandwich, I could put it in the parentheses or brackets. I was thinking about the next example. The parentheses or the brackets. So we start at -8. Our range begins at -8, and then it goes all the way up to positive infinity. Now, it is equal to -8. We do have a value where y does equal -8, but I never have a point where y is actually equal to infinity. So our range I could write in this form as well. All right, number 3, final one. Identify the domain and range of the graph. And this is the other graph in the OMHS lesson notes images. If you can't print it out, go ahead and just draw it. Come on, come on. There we go. So I'm going to begin here. This is not actually a quadratic. This is just some other kind of polynomial, but I want to review kind of how this works if this is not a continuous function that goes forever and ever and ever, because this is not. This is a piece of one. So let's start with our domain, which is explicitly talking about those x values from the left to the right. So I'm going to find my smallest x value, which if I'm looking on, and let me even highlight here, if I'm looking on the x-axis, the smallest x value I have is -11. And then that runs all the way up to our largest x value, which is 10, right? So our x values here, and I'm going to clear all this because it's a lot of mumbo jumbo. Our x values run from -11 up to 10. So I'm going to write our domain as these x values. They begin at -11, and it is equal to -11 because I have a closed-in circle. And then it runs all the way to 10, but it is not equal to 10. So I'm going to put the parentheses around that. I also could write this domain as an inequality. I could say that -11 is less than or equal to x, which is just less than 10. I use the less than or equal to because I use the bracket because it is actually equal to over here. Whereas on the other side, it is not equal to 10, so I used just the less than symbol. All right, so those are kind of two different ways I could write the domain. Now let's find the range. So now I'm going to find the lowest possible y value at the bottom, and I'm going to work my way up to the tallest y value at the top. So the smallest y value that I see looks like the y value of -9, right? I actually have 2 points that have that y value. There's a point right here that has that height. So our range starts at -9. Ooh, what's the highlighter? It starts at -9, and then it goes up to the tallest point, which isn't that far away, at -5, right? The tallest point on our graph has a height of -5. So our range is from -9 to -5, and it is actually equal to both of those values, right? This is a closed-in point, and it is equal to here. So I will use brackets on both endpoints in the range. And then I could also write this as all of the y values between -9 and -5. So -9 is less than or equal to y, which is less than or equal to -5. Notice that I use the or equal to in both because it is equal to both of those values. I do have both of those values for real in our range. Even though I have this open circle here at, what point is that? 10, -8. -8 shows up in our range in other places, right? I have a point right here that has a y value of -8. I have a point maybe right here that has a y value of -8. So even though there's a spot where it's not included, there's other places where it is. So our range is all the values between -9 and -5. Another way you might see this is -9 is less than or equal to f of x, which is less than or equal to -5. Please let me know what questions you have, and I look forward to seeing you in class.